We'll start this lesson off by explaining what failover clusters are and how they can help you. A failover cluster in Windows Server 2012 provides high availability and scalability to server workloads, including applications like Exchange, Hyper-V, SQL, and file services. And notice there that I said that Hyper-V is just one of the applications that failover clustering provides high availability and scalability for. In other words, failover clustering can be used for numerous functions. It's a Windows Server availability feature for anything that runs on top, not just specifically for Hyper-V. However, in this lesson, we'll be using failover clustering to provide high availability and scalability for Hyper-V. Before we get too far into failover clustering, you first need to know some terminology. First off, you've got nodes. Nodes are the cluster servers. In other words, these are the Windows Server 2012 hosts that are participating in the failover cluster. Then you've got failover. Failover is when a node fails. So one of those physical servers fails and other nodes take over for it. That's when a failover occurs. You've got cluster roles. Cluster roles are the software that make failover clustering work. And then finally, cluster shared volumes, or CSVs. These provide a consistent distributed namespace that clustered roles can use to access the shared storage from all nodes. So that's the terminology you need to be familiar with. We'll be configuring our nodes to perform failover using the cluster roles that we configured. They'll all be accessing the clustered shared volumes to share the namespace and access the shared storage. Here we've got a diagram, thanks to Microsoft.com, that depicts how Windows failover clustering works. So on the bottom, you've got a shared storage volume. In this case, it's an iSCSI target. In this case, they also have a 500 megabyte quorum disk. A quorum disk is accessed by all servers participating in the failover cluster, and it's used really to control the cluster, to break ties, and to know who's out there. However, starting with Windows Server 2008 and above, it's no longer required. So in this lesson, I won't be configuring a quorum disk. And then they've got a 5 gigabyte data disk on there, which is very likely, if we're running Hyper-V here, where the virtual machines would be stored in this shared iSCSI SAN. So both servers connect to the iSCSI SAN. They also have LAN connections. And then they also, in this case, even have a heartbeat network that goes between the two servers. Now that's recommended on a production network using failover clustering, but in my demonstration I won't have a separate heartbeat network. Now in this diagram we just have two nodes using Windows Server failover clustering, but of course you can have more than two. So that's a basic visual representation of how a Windows 2012 failover cluster would work. Two hosts connected to shared storage. Of course, that's the most important thing. You can optionally have a separate network for iSCSI, separate network for production, and another network for heartbeat communication between the servers. Now let's move on and talk about what's new in Windows Server 2012 failover clustering. I think you'll be happy to learn that there's increased scalability in Windows Server 2012 when it comes to failover clustering. Now you can have up to 64 nodes. That's 64 physical servers in a Windows Server 2012 failover cluster. That's up from 16 nodes in Windows Server 2008. With Windows Server 2012, now you can also have up to 8,000 virtual machines per cluster, an incredible number, and this is up from 1,000 virtual machines in Windows Server 2008. Server 2012 offers simplified live migration and quick migration of virtual machines and virtual machine storage. There's now support for Hyper-V replica. Search, filtering, and custom views are now available when you go in and configure failover clustering. Other new features you'll find in Windows Server 2012 failover clustering are service monitoring of Hyper-V virtual machine applications. That's the applications inside the Hyper-V virtual machines, for example, Exchange or SQL or SharePoint. Now you can restart virtual machine services or even move them to another node if there is a failure. There are cluster validation tests. Virtual machine priority and preemption are also available. These are all things I'll be demonstrating for you later in this lesson. And finally, additional features are memory-aware virtual machine placement. That means that a virtual machine won't be placed on a host that has, let's say, a limited amount of memory available. There's virtual machine mobility, which has to do with live migration and the storage migration features of Windows Server 2012. Failover clustering can now utilize those types of features when there are outages within the nodes. There's automated node draining. This is, let's say that you want to put a node in the cluster into a maintenance mode. Failover clustering can automatically use live migration and storage migration to migrate those virtual machines to another node in the cluster so that you could perform some maintenance on the server. Let's say perhaps patch the server or perform a hardware upgrade or hardware replacement like a failed power supply. And then finally, there are PowerShell commandlets now that can do all of these things in Windows Server 2012 related to failover clustering, which is great for those out there who want to script or just do things from the command line. And now we're moving on to the most exciting part of this lesson, which is performing failover clustering step by step. So what we'll be doing is we'll start off with some planning to ensure that we have what we need to perform a failover clustering configuration. I'll show you how to create a clustered shared volume, or CSV. We'll configure virtual networking. We'll test live migration, which is a great way to ensure that failover clustering has what it needs. And finally, we'll test failover so that you can see failover clustering in Windows Server 2012 in action. So with that, let's get started. Here on host 1 of our Windows Server 2012 cluster, I said the first thing we need to do is to do some basic planning. So you've got 2 servers, a minimum of 2 servers in this failover cluster. You're also going to need some form of shared storage. So with Windows Server 2012, you can use SMB3 shared storage. So we could have a third server that's providing our shared storage. We could also have an iSCSI SAN, and that's the option that I'm going to choose. If we go down to the Start menu, then into Administrative Tools, then into the iSCSI Initiator, notice here that I have done a quick connect. All I did is I typed in the name of my iSCSI SAN right here in the target, and I'm using the Starwind iSCSI SAN. They have a free version, and it is compatible with Windows failover clusters. Now, you have to keep an eye out for other SANs that are not compatible with Windows failover cluster, because Windows failover clusters requires a specific feature of iSCSI, and not all SANs have that. So I've set up this SAN. Actually, in my lab, it's running on a virtual machine that's running inside another hypervisor on another host. That's actually my SAN. Of course, you wouldn't do that in production, but to create the demonstration and to test and learn about Windows failover clusters. So I've set up that SAN. I typed in the target name right here. I did a quick connect, and ta-da, we have a iSCSI connection here to an iSCSI shared storage SAN. We can see the SAN listed here. If we go into volumes and devices, we have not yet mounted any volumes and devices, and you don't want to do that. That's not something you need to do. Just make sure you have a connection to the SAN and you have a cluster volume created over on the SAN available for the purposes of Windows failover clustering. So I'll click cancel here. Let's close this out. So that's the basic planning for creating a Windows failover cluster in a lab environment. Of course, the planning to create a Windows failover cluster in a production environment is going to be much, much more significant. And Microsoft TechNet has some great documents to help you get into that and analyze what's required to make sure that you meet all of those requirements, and also that you don't have any single points of failure in your production Windows failover cluster. So the next step in this process is to go down to Server Manager, and we're just going to click here to Add Roles and Features. Now, Windows Failover Cluster is actually a feature of Windows 2012. So we'll click through here. It's not a role. It's not listed in the roles. It is actually a feature right here called Failover Clustering. So if I check that, it comes up and it says, are you sure you want to include the management tools? Yes, we do want to add those features. Now that we've got failover clustering checked, I'll click Next here. And we'll check here to restart the destination server automatically if required. Now, this server is also a Hyper-V host. Of course, because this is in a lab environment, I don't really care that it has running virtual machines, but in a production environment, if you're going to restart a Hyper-V host that has running virtual machines, of course, you need to do that during some scheduled maintenance time. So I'll click yes here to allow automatic restarts. So this is a Hyper-V host, and it's also going to be part of the failover cluster. We're installing the failover cluster features, as well as the management tools and the module for Windows PowerShell, so we could administer failover clustering through PowerShell. I'll just click install here, and this will take a minute. While it happens, let's go over to our other host that's going to participate in the cluster, and we'll go through the same process. Here on host Hyper-V 2, again, I'm going to verify that we have connectivity to the iSCSI SAN. I'll go into the administrative tools, then into the iSCSI initiator. And I'm glad I did that because it says the iSCSI service is not running. So I'll click yes here to make sure that it starts up automatically when the server starts. And then we'll do a quick connect here to our iSCSI SAN. So it's iSCSI-SAN-2. I'll click quick connect. It finds the iSCSI target. It says login succeeded. I'll click done here. And we've got it listed now. I'll say OK. And we just made our connectivity that's required for the failover cluster. So now let's go ahead and go to the dashboard here in Server Manager. I'll click Add Roles and Features. We'll go down through this, click Next, Next, add a feature here to Hyper-V 2. And underneath Features, I'll check to add failover clustering. We'll click Add Feature to ensure that we include the management tools. I'll click Next. I'll restart the host here if needed, and say Install. And again, this will take a few minutes, so let's go back to the first host we started this installation on. All right, back here on host Hyper-V 1, it says installation succeeded of the failover clustering tools and the feature. I'll click Close here. Let's minimize Server Manager, go down to the Start menu, and now look at this. We've got the Failover Cluster Manager here and Cluster Aware Updating. Both of these were added when we installed the failover clustering feature. So let's go ahead and run the Failover Clustering Manager. And by the way, you need to be a Windows Active Directory administrator or administrator equivalent to do this. You can't be local admin to create a failover cluster. So this brings up the Failover Cluster Manager. Here inside the Failover Cluster Manager, we've got a few very obvious things we can do here, and that is to validate a cluster configuration, create a cluster, or connect to an existing cluster. So let's say you were running this on your desktop Windows operating system. You could connect to another cluster that was already created. But the most important thing when you're just getting started like we are is to run the cluster validation. That's going to go out and check our servers and our storage to ensure that we have everything we need, because there's so many little pieces that make up a successful cluster. So let's go ahead and click Failover Cluster Validation here. And it says that this wizard runs validation tests to determine the configuration of servers and storage that will be making up the cluster. Now, even if this validation wizard does validate your servers and storage, that doesn't mean that it's fully supported by Microsoft. It's only supported by Microsoft if it's running in the supported configurations and if that server and storage hardware is certified by Microsoft in Windows Server 2012. So I'll go ahead and click Next here. We'll type in the name of one of our hosts, host Hyper-V 1. I'll click Add here. And then the second server that's going to participate in this new cluster, host Hyper-V 2. Again, I'll click Add. We've got both of our servers listed here. I'll click Next. And here I can run all tests or run only the tests that I select. If you run only tests that you select, let's take a look at all these tests. So it knows that Hyper-V is running on these hosts, and this is going to be a Hyper-V failover cluster. But look at all the tests that it's going to perform here. List the servers, validate compatibility, check the memory resources, processor resources, ensure that the roles installed, and validate matching processor manufacturers on both of the servers. It's going to perform an inventory of storage and servers, listing out adapters, listing out running processes, BIOS. It's going to validate the network configuration, IP addressing, firewall, storage, listing out disks, potential cluster disks, validating the cluster shared volume configuration, validating SCSI-3 persistent reservations right there. That's the feature that my SMB grade iSCSI storage area network was missing, is the SCSI-3 persistent reservations. And that was when I moved to using the software-based StarWind iSCSI SAN here in my lab environment. And then finally, system configurations, validating Active Directory configuration, operating system additions, and that we have the same processor architecture. So those are all the tests that it's going to perform. If I click Previous here and go back, I'll just check to run all the tests, and let's click Next. Okay, it says it's about to test the 2 servers that I specified, and it's going to perform this very long list of tests here. I'll click Next, and it goes through the testing process. This will take just a minute. And here it tells us that our failover cluster validation testing has completed, and it appears that all the tests were successful. We can scroll through here. You can see success on everything. Of course, we did get a few warnings, just some cautionary things there. But overall, it says that the testing has completed successfully. And you may want to go in and view the report here, which is a very extensive HTML report of everything that was tested. In our case, let's go ahead and pass on that. I'll just click Finish here. And this brings up the Create a Cluster Wizard. So this is going to walk us through the process of creating the new Hyper-V cluster. So to get started, I'll just click Next here. And we'll start by giving our cluster a name. So I'm just going to call it Hyper-V Cluster 1. And we also need to give it a dedicated IP address. So it has to be in this network, which is my local subnet 10.0.1.0. And I'm going to type in an IP address here. So I know that .5 is available. I'm just going to type in 5. And this is going to be the single IP address for administering the entire cluster. I'll click Next here. And then here's a final confirmation. We're about to create a new cluster called Hyper-V Cluster 1. We've got 2 nodes in the cluster, and the cluster IP address is listed there. And by default, we're going to add all eligible storage to the cluster. I'll click Next here, and we're creating our new Windows Server 2012 Hyper-V Failover cluster. All right, and it says you have successfully completed the cluster creation. I'll click Finish here. The Failover Cluster Manager automatically connected to the new cluster. And take a look at this. Here we go. Here's Hyper-V Cluster 1.wiredbraincoffee.com. We have roles here, and we'll be creating a role in just a minute. Examples of roles would be a high availability file server, DHCP server, or in our case, a virtual machine. We have nodes in our cluster. Host Hyper-V1 and Hyper-V2, both of them are showing their status to be up. We can add additional nodes here, pause nodes, resume nodes, show critical events about our nodes. We can go into storage, and if you look at the disk, right now we don't have any disk and we don't have any pools added. Those are something we'll need to do. If we look at networks here, we have a cluster network. It is enabled and up. And then we can look at shared cluster events down here, which so far we have none. So with our new cluster created, here in our cluster, the first thing we need to do is to provide some storage for the cluster. So if I go down here to disk, and I go over to Add Disk, it looks like we've got a problem. It says no disks are suitable for the cluster. So we can say OK here, and let's go down to Computer Manager. And here inside Disk Management, for cluster testing, I know I created a shared iSCSI LUN, 30 gigabytes in size, and I see here disk 2 on this host is 30 gigabytes in size. Right now its status is offline. I'm going to right-click here, bring it online, then right-click again to initialize the disk. We can take the default here. I'll say OK. Notice it is a basic disk now. It's initialized. It's online. Let's right-click on it, and let's do a new simple volume. This one will be 30 gigs. I'm not going to assign a drive letter at this point. We'll give it a name, though, and we'll say that this is cluster disk 1. Perform a quick format using NTFS. I'll say next there and finish. And there we go. Cluster disk 1 is online, NTFS formatted. So let's minimize this. Go back to the Failover Cluster Manager. I'll click Add Disk here again. And now we have a cluster disk that we can bring online and add to this failover cluster. So I'll say OK here. And there we go. Our new cluster disk is online and it's available storage. The second thing we need to do is to select the disk here and click to add this to the cluster shared volume. I'm just going to select that option. It takes it offline, it brings it back online, and now this is a cluster shared volume. So this is essentially a multi-user disk being used by the multiple nodes in this failover cluster. This is our cluster shared volume. It's very important that we have a cluster shared volume. That's where our virtual machines are going to be stored in the case of a Hyper-V cluster. With our new cluster disk created, now let's go up here to the top of the cluster and discuss the next step in this process. With our cluster network, our cluster disk, and our cluster nodes all in place, the next thing we need for this Hyper-V failover cluster are virtual machines. Those virtual machines would be added underneath roles. So let's go into roles here. And keep in mind that Windows Server 2012 failover clustering isn't just for Hyper-V. You can add any number of roles to be provided by the failover cluster. So if I go in here to configure a role, click Next here, look at all the different things that failover clustering can provide high availability for. DFS namespacing, DHCP server, distributed transaction coordinator, file server, applications, scripts, Hyper-V replica broker, iSCSI target server, message queuing, Win server, and of course virtual machine. So when you say you want to provide high availability here for a virtual machine, this would be for an existing virtual machine that's running on one of the existing Hyper-V nodes that are part of the cluster. So keep in mind also that just because you're running failover clustering on two Hyper-V servers doesn't mean that those virtual machines running on those servers are automatically protected. You have to go in here underneath roles and add a role for virtual machine high availability protection. So if I say next here, I'm being given the option to add high availability for one of the virtual machines that's already running on one of my Hyper-V hosts. In this case, the virtual machine is called Win 2012-1. It says it's running, and it's running on host Hyper-V1. So here, if I check this, I can say, yes, I want to add high availability for this existing and running virtual machine. There'll be no downtime for the virtual machine. We'll just add the high availability feature for it. So I'll click Next here. I'll click Next. It says that high availability was successfully configured for this role. And if we scroll down here, there is a warning. So let's go ahead and click View Report. And notice here it says that the disk path C:\users public documents Hyper-V is not a path to the storage in the cluster or to storage that can be added to the cluster. In other words, this virtual machine has been added, but its disk is not accessible by all of the hosts in the cluster. So if there were an event on the host that this virtual machine is running on, the virtual machine would be attempted to be run on another host, but there would be no access for that host to see the virtual machine disk file for this virtual machine. So in other words, the high availability recovery of this virtual machine would fail. So we have something yet that we have to do to complete the high availability protection for this virtual machine. And in fact, it tells us here, it says you can change the location of the virtual machine and its files to a valid cluster managed storage location using the Move Virtual Machine Storage dialog in the Failover Cluster Manager. So let me show you what that is. I'll close this report out here. I'll say Finish. and we do have the virtual machine. It says it's running. It's currently on host Hyper-V 1. It has a priority in the failover cluster. But if we go over here to move underneath the virtual machine, of course, you've got live migration and quick migration to move the running virtual machine from one host to another, but it's already running in this case, and there's nothing else on this host. We don't need to move the virtual machine's configuration and memory and CPU processes. We need to move the virtual machine storage. So let's go into virtual machine storage, and here's the virtual machine. If we expand this out, here's the different files that make up the virtual machine. Notice, of course, by default, they're not all in the same location. You've got the virtual machine disk file, you've got snapshot files, you've got second level paging files, and configuration files. So the cluster storage is down here. See here, cluster storage, and there's volume 1. What we want to do is drag and drop this virtual machine and all its associated files down to volume 1 in the clustered storage. So I'll release there. We can see we're going to move 21 gigabytes to the cluster storage volume. I'll click Start. And if we scroll to the right here, it says it's starting the virtual machine storage migration. So let's actually go out to Windows Explorer and see what's happening. If we scroll down, underneath the C:cluster storage volume 1, which is where we said we want to put this virtual machine, notice here's the hard disk image file being created. There's the name of the virtual machine. So currently this is 69 megabytes. And this is just going to continue to grow. There now it's 331 megabytes. This file is being moved actually from the local hard drive on that Hyper-V host server to the cluster shared volume. So I'll refresh where you can see it's growing here. Now it's about 400 megabytes. We've also got underneath here, we'll have the virtual machine configuration file and the snapshot files as well. We're up to 430 megabytes. This is going to take a few minutes, so let's close this out, and I'll come back as soon as the virtual machine storage has been migrated. But keep in mind, this virtual machine has been running. It's providing applications to end users. It's never gone down, even though we've enabled high availability on it, and we're moving its virtual machine hard drive from one location to another. While this is happening, let's look at another way to get virtual machines into your failover cluster. So I just showed you how to move a virtual machine that's currently running on a Hyper-V host into the failover cluster and then move its virtual machine hard disk to the cluster shared volume. Now let me show you how to actually create a new virtual machine that's stored in the failover cluster by default. To do that, you go over here to Virtual Machines inside the Failover Cluster Manager roles and go down and click on New Virtual Machine. From here, you'll select the initial placement for that virtual machine, the host that you want it to be running on when it's first created. I'll take this default here of host Hyper-V 2 and say OK. And then this is going to bring up the new virtual machine wizard. Now, this is the exact same new virtual machine wizard that we've used over inside Hyper-V Manager before. So before you just click Finish here or click Next very quickly through it, something I want to point out is that all the virtual machine files that are stored on disk need to be inside the CSV, or the cluster shared volume. That's that cluster storage that we created. Otherwise, you can create this virtual machine. You'll get a warning at the end. The virtual machine will say it has high availability, but if the host that it's running on fails, those virtual machine files won't be accessible and the virtual machine won't come back up after the failure. So we have to be very careful here where we place the files for this virtual machine. So I'll click Next. I'll give this virtual machine a name. Let's call it Exchange Server 1. And then check this checkbox right here to store the virtual machine in a different location. I'll click Browse. I'll do the drop down here. I'll go to the C drive, and I want to go into this clustered storage, into Volume 1. And this is where we'll be placing the virtual machine configuration file. I'll click Next here. And let's not worry about sizing the virtual machine hardware at this point. I'll just take the default for memory and networking. And then again here, notice this. Because I selected to store the virtual machine in a different location, the location for the virtual machine hard disk has also changed. So it's going to go now into the C:cluster storage volume 1. That's where it must be for this virtual machine to be protected by the failover cluster. It needs to be on that cluster storage. So I'll click Next here. We'll install an operating system later. I'll click Finish. and we'll create the new virtual machine, which includes the virtual machine configuration file and the virtual machine hard disk, all of which will be placed on the cluster storage. At this point, high availability is configured on the virtual machine, and it tells us we're successful, and we even have a report here that's reporting 100% success. Now, if you hadn't have changed the location for the virtual machine hard drive or configuration files, you would have gotten a warning here, and you could have viewed the report to see that your files weren't in the right place. I'll click Finish here, and now we've got our brand new role. This virtual machine is now protected by high availability. We've got one virtual machine on each of our hosts. Let's go ahead and power this virtual machine on. With your Hyper-V virtual machines added to the failover cluster, one of the first things you're going to want to do is to test the failover clustering and high availability features. Now, this isn't an advanced lesson on failover clustering. There's multiple ways that you can test your failover cluster. I'm just going to show you two quick ways. The first way is if you go up here to the top of the cluster, you can actually go over to the right-hand side here, underneath More Actions, and you can simulate a failure. This doesn't actually bring anything down. It's just a simulation to ensure that the cluster communications are working, and that if cluster communications were lost, that the failover clustering features would take effect. So I'll click here to simulate a failure. It says, are you sure you want to do this? This could cause the clustered role to be moved to another node in the cluster, and it could interrupt currently connected clients. Now, if there is an interruption, it's a very small interruption, but still, if you want to do this, you should do it in a lab environment or during a maintenance window of a production environment. I'll say yes here, and it says the cluster network name is not online. And very quickly it came back, and now we've got an event here. If I click on the error, and you can see here it says the cluster name, in this case Hyper-V Cluster 1, the network was unavailable and the cluster group failed. We can go back to our roles here, and it appears everything's still running. Our nodes are both up and online. The virtual machines on each node are still running. And our cluster storage is also online. So that's one quick way to test the failover clustering network communications to ensure that everything is as it should be. Another way is to actually go to a node in the cluster. For example, we've got this Exchange server virtual machine running on host Hyper-V2. I can go to this host, and I can go over here to More Actions, and I can actually stop the cluster service. Now, what should happen is the virtual machine Exchange Server 1 that's running on this host should be automatically restarted and moved to the other node in the cluster, host Hyper-V1 in this case. So I'll just stop the cluster service. It says, are you sure? I'll say yes. And then if we go up here to the roles, notice Exchange Server number 1 running on host Hyper-V2. If we give it just a minute here, because the cluster role was stopped on that host, Exchange Server 1 virtual machine should be moved to host Hyper-V1. And there we go. The virtual machine is automatically restarted on host Hyper-V1. So those are two quick tests that you can perform on your failover cluster in Windows Server 2012. So with that, let's go back to our slides. Now that we've configured and tested Windows Server 2012 failover clustering, this lesson is complete. Thanks for watching this lesson on configuring and using Windows Server 2012 failover clustering with Hyper-V.